Hello, everyone. I'm John Owings, and I am with the Portworx business unit for Pure Storage, and I'm the director for Cloud Native Strategy. And today we're going to talk about accelerating development or accelerating productivity for developers with a database platform as a service. So, what does all that mean, and what is it built on? We'll go a little bit of an overview. First, I've been with Pure Storage for a very long time, and I've worked with containers the last 5 years. I have a blog if you'd like to visit. I would love that. Lots of things that I've learned along the way. It's there, crashloopbackoff.io. And you can find me on Twitter, and I've been a VMware V expert for many years now. So yeah, so we could just jump right in, and that really of why I do this is I like to solve problems and help people, and it's not an interactive session, but we actually ask why. Why do you do this? And I, at least working with customers around the globe, it is the same, right? Enjoy solving problems, making people better, like making things work better. And obviously all of us like to build a business. And today we'll talk about some outcomes, right? We're going to focus on this faster time to innovation on the side, but this is something I see from customers all around the world that are building platforms. So platform engineering, SREs, those types, they want to be able to innovate, and then still have security built in from the start, or they have this cost optimization, like I have to save money somehow. And then obviously developer and operations productivity. So we're going to talk a little bit of combination of productivity and faster time to innovation today, and how Portworx and Pure Storage can help you build that. First is when you first start to get into this, there's a lot of options, and there's a lot of knobs. And honestly, as an engineer, as a platform engineer, working in DevOps, we love to be able to tweak and turn and test things. And so, this picture, you can see there's lots of things to change and do. So with all those options, how do we make this simpler? Like, how do we make this easier and faster without having to keep track of thousands of different things? So that's our first goal. And with the same in a modern cloud native stack, right, there's lots of choices, and this is simplified. Usually you would hear some kind of cloud native or see some kind of cloud native landscape from their website where there's literally thousands of vendor logos and open source project logos you can choose from, and how to get them. We'll simplify it today and say, we're everything that we do, we want to aim at, like, how does it work on premises? How does it work in the public cloud, and even at the edge? We'll kind of simplify that down and call that hybrid. That's hybrid cloud. And then what platform do we use or build on top of that? Which often I see in most of our customers is one of the cloud provided versions, or Red Hat OpenShift. There are others out there like VMware Tanzu or Rancher, those types of things. And then finally is this cloud native data management piece. And with that, we actually had this data storage protection longing or thing, and it was built natively into into Kubernetes, into the container orchestration platform. And it was eventually kind of formed into this CSI, right? So the container storage interface, it all that is a API, a definition of how Kubernetes or any container orchestrator can interact with a storage device. Now, there was a couple of different approaches when we came to that, right? There is a mindset that came from a virtual machine world, like a VM world. This is infrastructure centric. It is based on tying every application to a piece of infrastructure, and that is very much what all of the storage vendors, including Pure Storage, did initially when CSI was released. And what that does is it wires maybe not physically but logically actual applications to storage devices. So what we had was really kind of two approaches to being able to provide data management for a containerized application. Now, the first one came from kind of the traditional legacy mindset, which was center it around a VM, center it around the infrastructure. And honestly, that is what Pure Storage did as a storage vendor. And if you look at every other storage vendor, basically created a way to just force their hardware solution into being able to work with these applications. Now, honestly, as Pure Storage kind of proceeded with that over the first couple of years, noticed that there was things that were just couldn't happen without being able to become what we see on the right here, which is an application centric way to approach your data management, right? And what that means is, hey, let's actually build the storage around the application, build the storage around, and have it be separated and still use a storage array, still utilize cloud storage, but have that abstracted in a way that now you can provision the app, observe it, do everything, and it's never forced to be tied to a specific piece of hardware. So you never have to. You can use a Pure Storage array. You can use other vendors' block storage arrays, and it will work fine. But also, you'll have the same experience in the cloud, and you'll have the same experience if you have different types of storage, right? So it should be able to be portable. It should be able to scale, which was another big issue with physical hardware, and it needs to be modular and agile. So we developed this platform, right? We let the pretty animation marketing made for me go there, but and it really starts with Portworx Enterprise, which is a distributed layer to allow you to build storage automation for Kubernetes. Then on top of that, right, you have Portworx Data Services, is what actually we're going to focus on today, and then Portworx Backup and Disaster Recovery, providing business continuity. If you have any kind of compliance or data retention requirements, you want to make sure that you have these things in place. And Portworx Backup, actually, I'll say it here in a second, it does not require Portworx Enterprise. You can back up any kind of CSI-based storage solution that exists. So, so we have this database as a service. This platform is in use across many customers in that are kind of down the road in their journey of deploying cloud native applications, right? So it could be any application. Like you see, there's lots of logos up there running on any distribution. We honestly have customers using all of these, and then any infrastructure or any cloud, right? It could be any of those. And what that gives you, that platform, because it's abstracted, is some really cool things around being able to manage the storage, manage the performance, create migration paths, so I can now move from one cloud to the other, or I can have hybrid applications like we've been promised over the last 10 years. So the first thing, and I'm going to come back to this deeper, is Portworx Data Services, and this is an abstraction layer. This is where we're going to look at. This is built on top of Portworx Enterprise, and it allows you to abstract away the complexity of Kubernetes. So now there is a single API, a single operator, a single click for a database service that you can give. If you build this platform, that now your developers can quickly and easily grab these open source databases, and some of them are not, so we have Microsoft SQL in there, so it's not all open source, but you can use these data services quickly and easily and fully supported by Pure Storage in order to accelerate what your users or what your developers need to move forward. The storage automation piece, like there's a couple of really key things in there, like that I didn't mention a second ago, and that's that thinly provisioned Kubernetes storage. What that really means is the ability in the cloud to provision and auto scale the data just like you would the compute. And so now I can provision what I need today, and let it grow as my need grows, and I no longer have to be stuck with, possibly over provisioning, because none of the cloud providers will, give you a break for leaving the provision volumes empty. So you pay for what you provision, and with Portworx now we're able to kind of save you lots of money on that. And there's a couple of customer examples. Uh, Backup and recovery, right, is important. Now it backs up to, either a object store, so it could be S3 or a blob store in the cloud. It can be on premises FlashBlade. It can be any other, S3 compatible, and now also with the latest release, it can be any kind of NFS store. So you can back up to those in a few clicks. You can create policies around that, and then provide self-service backup and restore to your developer teams. So now with that security built in, you can actually say, hey, instead of opening a ticket and waiting for days for, a team to come and restore the data, the developer themselves can go, if they accidentally delete something, they can restore it themselves. So obviously with that, like the automated capacity management, like I mentioned earlier, with the auto scaling for the cloud, we call that autopilot. That is a great ability there. The data services, actually, this slide's already old, so we're constantly adding them. So there's actually 12 data services on there now. And then other things like application IO control, being able to provide a QoS for your application so that a particular, in a container world, there can be lots of services, lots of interdependencies, and you don't want any one noisy neighbor to cause cluster issues when it comes to IO on an application. So that way you're able to check that, and you're able to keep that from causing issues. All kinds of goodness there. And the volume migrations across any cloud. So I can move that data to another cloud or to another Kubernetes distribution if I want to. So if you're on Red Hat today and you love it, you may move into Rosa or something, or ARO that's in the different public cloud providers. Or hey, you decide we're going to go onto Google, and so now we need to move everything to GKE. What Portworx provides is that common platform, so now I can move things to any of those clusters and do it in a way that's either scheduled or automated. It's all done through code. So high availability, lower your costs. I promise we'll soon be out of all the marketing slides, and I'm going to show a demo. The big things are, this is not just no one running this. This is real customers, real businesses out there around, T-Mobile moving the development time down from 6 months, deployment time 6 months to minutes and hours. The very, a zero RPO, fast RTO, RBC is getting, and even the cloud cost optimization for Audi is what I was talking about earlier, is, being able to reduce that cost and have a better utilization for what you're paying for with your cloud spend. So it's very important there. More quotes, right? So, the interact with Kubernetes, it just works. That's T-Mobile. And, having high availability, from Comcast is a cable provider in the US. We have, Audi also, lowering the price and having more performance, right? So that's super important. And then the RTO, being able to fail over quickly is extremely important to a banking business that has to process, transactions and all those things. So dive in, probably spend a little more time on the platform as a service. So hopefully I'm not, going too fast, but what we have is this platform with Portworx Enterprise that enables you to do a lot of things, and it gives you a lot of power when it comes to managing data when they are in Kubernetes. And this is a thing we see a lot of big customers doing. Now, how do we make that simpler? How do we make that easier? And that's what Portworx Data Services is really about. Now, the first question I always get when it comes to this is there's an operator for this. There's an operator for MySQL or Elastic or Postgres. I can deploy those all right. And that is true. But what we aim to do is consolidate those into a single API and a single instruction set. So now, instead of learning all of the intricacies of Kafka or MongoDB, you have, as a platform provider, you're now able to provide this wide range of services without having to hire specialists in each and every one of these. Now, what that does is that really frees up your database and data teams to work with the applications they're comfortable with without having to become experts on running them in Kubernetes, right? There are operators, there's things like that. But what we do is we consolidate that down into a single API, a single user interface, which I'll show you in a second, and deploy that from this wide catalog, get all of the 24/7 support, and avoid lock into, other platforms that maybe, only exist within a single cloud or within VMs, and operate all this from one place and have that hybrid management where I can have workloads in different clouds all within a single control plane that we run for you. What that does is that speeds up the time to market for new apps. So as developers are creating new things, like they're able to quickly get what they need. There's no longer waiting hours, days, weeks. It's just a few minutes. If that 3x improvement in that database admin. So the DBAs themselves will free up cycles from having to manually manage these things. And this is beyond just deployment, but day two, backups, upgrades, those types of things are all built into the platform. And any database, it will reduce the cost versus like a, a cloud-based database as a service, and also improves that fault tolerance because we're able to spread those workloads across availability zones and utilize the high availability of Kubernetes. We can provide that. So getting further into the databases, right? So developers, they're developing these end user apps, web e-commerce, mobile applications, um, AI/ML, those types of things. And it comes down to many of these tools kind of can become a whole project in and of themselves. So a database as a service or a data search as a service or analytics, like I want to be able to provide, you know, Jupyter Hub as a service, those types of things, or even streaming data as a service. All of those tools can be their own little silo in and of themselves. And at scale, right, to be able to provide more than just the deployment of them, like, yes, they came up and they say ready, but is the availability, the secure access, the migration of that, backup, disaster recovery, and compliance, like being able to report, like, here's what we're running. Having all that in this control plane allows you to now provide those services, no matter which one of them they are. And you can see it fits in there. Yes, we're going to reduce your cloud costs. And so it comes down to, we have customers, most of them have, at least of our existing customers over the last 5 years, they've built this data platform on the left or on my left. Maybe it's on your right, depending on how you're facing the screen. But the data platform, right, they've built that. Now what they're looking at today is they want to build their own managed platform to provide these services as a PaaS. And so what we want to do is give you the choice, right? We can let you build it yourself, and you can continue to do that, or you can add this database platform as a service to abstract and provide all these services that and we've already built, and kind of give you a shortcut to what you really want to provide to your end users. And now the demo, because I think demos are more fun. So to minimize this, Okay. Actually, hold on. Let me explain what we're going to see. So this is a typical platform, or just a sample application, but it really involves not more than just a web page and a database, right? So um not that everyone out there is providing food delivery service, but this is kind of a sample, right? So we have a front end that website that provides food delivery, and we have to authenticate and register people, and that's done by MongoDB, which is a service we'll deploy via Portworx data services. Those orders that customers make are submitted into a Kafka queue. In that queue, there could be subscribed restaurants that could pull those orders from that Kafka queue. Um, right now in this sample, we have a consumer that will take those and write them into a MySQL database, so you can see your history of your orders. So it's a kind of a sample way to show that there's doing this by hand can be very complex, but with PDS we can make these pieces very easy, and make the deployment quite simple and smooth. So let's jump over to my code here. See if I can get my screen up and ready. This one. All right, John, you didn't have it ready. Here we go. So this is just a sample. This is the repository for that sample application. It's actually all within a Helm chart here. We can drop all these environment variables in here, and because it's all driven via an API, we can actually automate all this, but we'll let you kind of see how we do this from a manual standpoint just for this talk, for this demo, so you guys can see kind of what's happening behind the scenes as we run this demo. So we will now go in and find PDS. It's in here somewhere. There it is. It's in the wrong screen. That's why you couldn't see it. So this is the initial dashboard for Portworx data services. So you can see that there are many services running with Postgres and MySQL. Within this, though, we have a settings button that only admins could see. So I'm an admin, and we can see from that we have deployment targets. Each one of these is a Kubernetes cluster in different environments. So there's Red Hat, there's EKS in Amazon. There are clusters from anywhere from the United States. There's one in Singapore. Some of these are in our lab in Staines. So there's a little bit of everything everywhere, all managed within this same platform. You can see from here, though, like there's a chart, a Helm chart that actually runs the agent that allows these clusters to register with the control plane. And some of my colleagues have not updated yet, so you can see it actually tells you, hey, it's time for you to upgrade. Now this just provides the command, like you cannot do damage to your target clusters from this control plane. We provide the command you need to run locally on your Kubernetes cluster. So other than that, there are other options. We won't bore you a ton with those. We will get right into deploying our needed data services. So first, we're going to deploy a Kafka. So we just be able to click one, deploy data service. I'm going to say Kafka, and we're going to call this, we're going to call this DevOps. Oops, I can't spell today. DevOps demo, right? And we're going to deploy it on my cluster, which is this one here, PD in EKS. We have our PX delivery namespace, and we're going to provision a load balancer. This allows the services to talk to each other external from the cluster, but these are actually internal load balancers. It does not expose them to the internet, because that would be very bad. We're going to choose our application configuration because we're not doing anything super complex. I'm going to do a small heap, and that actually gives me an internal uh, craft uh, um, database to track these. I don't need an external zookeeper or anything like that. I'm going to leave that at small, and we need 3 nodes to deploy that. And I'm going to select this right here. So these are just our replication options for the storage, and we hit deploy. So as that deploys, we will go back and we will also deploy MySQL. Make sure I have everything I need here. So that's going to take just a second to deploy. We're going to also come back in here and say, okay, we need MySQL. And we're going to call this on that same cluster. Put it in our delivery namespace. And this one, we only need a single node of MySQL. You can put more, like it will allow you to scale up MySQL so you can have read replicas and those types of things. And we could also even schedule a backup, for MySQL, we can schedule a daily backup if we'd like, and say, yeah, let's go to one of these targets. But for now, since those are not my targets, I don't want to be backing up to somebody else's bucket. I will leave that as it is and hit deploy. Okay, so that should be launching. Let's go back to the overview. These are still, so you can see it says unavailable. It's still deploying. It's starting. You can see one of the nodes is up, so we will allow that to keep working while we move on to our MongoDB. And that is right here. We're going to call this also DevOps. So put it back in my cluster and put it in our delivery. We only need a single node of that. We could do more as well. And deploy. So as that rolls up, we should start to see these finish deploying here in a second. And we will get some information. So first, as that's deploying, it's actually already deployed a endpoint. So these are registered DNS endpoints. I'm going to take that. I'm going to put it into our Helm chart or values file for Helm here. So we're going to save that real quick so I don't forget to save, because it won't work if we don't save it correctly. And let's go back and get the password. That's super important. And so they auto generate this password. It doesn't expose it, and we can copy that and now put it into this code. Oops. Oh my gosh. How did I do that? There we go. Selection skills are not working today, so we'll just paste that new password in there, save it, and we'll do the same for the rest of these data services. So close that. We can see that Kafka is now up and available. MySQL is now ready, so we'll take this name and we'll paste it into here. So there's MySQL. Oops. I'd like to have that in there. Password. Oops. And zoom. I just accidentally closed VS Code. I probably did. There's that password, and we'll delete this out of there while we're in here. Well, here, MySQL's up and running. See what Mongo is doing. It is, oh, insufficient CPU. Oh no. I think I ran out of CPU. Let me see if I. It's my danger of having too small a cluster. Okay, get pod. Luckily, I'm the admin of this cluster and I know what I can do here. We can actually go in, select that cluster, apply. I can find, oh, look at all these services, test, and I can actually delete them. And while that deploys, I'll show you a couple other things inside of this. There will be some billing and some backup dashboards coming soon. That's why that says coming soon. Inside of this, you can see that the data services that are available are, anything from Cassandra, Console, Couchbase. Brand new to PDS is Microsoft SQL Server. Obviously, you need to have a license for that, but it will let you deploy either developer edition or enterprise, depending on your key. So that is a bring your own license. And then the same for MongoDB. It's the enterprise version. So you have to bring your own license as well. The rest of them, though, are open source versions that you can use, and we support everything that is running on top of PDS. So if you have any issues with Cassandra or deploying it or upgrading it, you can call Pure Support, and we'll be able to help you. In addition to that, like there's the ability to manage multiple users. You can see my team here. There's lots of them are available to go. And then also there's backup targets. Like I said before, my backup target wasn't in here, but it can be a FlashBlade, it can be Amazon. There's lots of different places it can target. So that's nice. And let's see if we're close to getting our Mongo running. It's gonna come up. It says green here. So we're gonna start pulling the connection information. Should say healthy here in a second. Copy this into our connection strings here. Now you could build a GitOps workflow that could actually pull all these values from the API fairly easily if you'd like that. So now that we have those saved and our MongoDB is now available and healthy, right? So that's a good thing. We're doing well there. And so now what we'll do is we will launch this Helm chart from our VS Code. So let's get that. There we go. And we'll make this quite easy by going into deploy Helm. And from here, we will run Helm install PX delivery. Spell it correctly. Make sure everything else is good. And this will launch that Helm chart. And if everything is happy, it'll work. And we should see those services start to come up. Can you get minus? There's our data services. You can see here there's a PX delivery container about to start and a consumer. Those are the two parts that we're launching there. They are currently running, which is nice. Once that delivery pod is happy, should be able to log into it. Oh, beautiful. It's pending. which is almost a good sign. All right, so that's up and running. That's nice. But what we need to do is make sure that this namespace is good. And I think I've run out of load balancers. So hopefully this doesn't happen to anyone in real life, right? Is PX delivery. Um, okay. Mhm. All right, so now we have our load balancer name here. We should be able to put this into my browser, which is right here. And we're going to put this in here. And now our food delivery business is up and running. I can log in. I don't have an account, so I need to register. And we can say, John Owings. Email address is jo at purestorage.com. Storage. Super secure password. We'll put some information in here. I am in Atlanta, Georgia. And so now I can log in. That login hits our Mongo database, and now I can place an order for barbecue because I love barbecue. So we'll have some pulled pork, some French fries. No, 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 we don't want French. Yeah, we'll get French fries, and we'll also get cornbread and some sweet tea. You probably don't have that in Europe, but it's more sugar than you can possibly count inside of the tea. So we'll hit place order. And so that order is now placed. We can actually now click order history. We should be able to, that order is going to go into the Kafka queue, and it's going to take a second for it to show up in our history. So we should be able to refresh, and there it is. There's our order. So you can see how the interaction between those data services is all very nice and neat. And if we go back to our window running the Portworx dashboard, we can see now let's just go to Kafka, and we can go to metrics, and you can see that there's now data going in and out of those. Now, each one of these metrics dashboards is built for that particular application. So there's application details around partitions, which is a pertinent stat for a Kafka cluster. And you can see here there's failed producer request, total producer request. So this is like, hey, it really just submitted a couple because we're not really under a big load. But you can see that there's things that are in there failed is at 0, and messages in and out, right? So that you can see that at one little point in time there was a couple messages that went in. So that was our order that we made. So with that is the end of the demo. Hopefully that was interesting to everyone, and you can see how those interact. And if there are more questions, I'd love for any of you out there that are watching this to find out more from our website. You can contact us. If you go to portworx.com, you can find a way to contact us. You can also go to central.portworx.com and sign up for a free trial of Portworx Enterprise, and you can actually submit to get a account provision for Portworx Data Services. We can work with you with our local teams to do that. Obviously, find us on LinkedIn, Twitter, any of those things. You saw earlier my Twitter handle was there, so you can find me. And if you have any other questions, let us know. And we're very happy that for the time, and hopefully this has been really good for everybody. Thank you very much.